In this video, I'd like to show an example for integration by trigonometric substitution method. Before starting the example, you need to know the formula for three cases. Once you determine which formula should be used, then you should be able to draw a triangle based on the expression type. Let's take a look at the example. Evaluate the integral of x cubed dx over square root of 4 minus x squared. First of all, match the expression in the question with the table. Since u is a function, it seems to be matched with the second formula, square root of a squared minus u squared type. Since a stands for some constant, a squared should be 4, taking square root of a squared to get a equal to 2 in this case. According to the table, it shows u equal a sine theta, let x equal 2 sine theta. Next, since there is a differential dx in the question, we need to take the differential of x. Taking the derivative of x to get dx equal 2 cosine theta d theta. Lastly, we need to substitute the expression of square root of 4 minus x squared in terms of theta. Since we let x equal 2 sine theta, substituting 2 sine theta into x to get the square root of 4 minus bracket 2 sine theta to the square. Expanding the square and taking the common factor 4 to get the square root of 4 times 1 minus sine square theta. Since cosine square theta plus sine square theta equal 1, rearranging the identity to get 1 minus sine square theta should be cosine square theta. Taking the square root of 4 cosine square theta to get 2 cosine theta for the expression. Now, rewrite the original question in terms of theta and d theta. For the x cubed term, substituting 2 sine theta to get 8 sine cube theta. For the dx term, we have 2 cosine theta d theta. For the last one, square root of 4 minus x squared can be replaced by 2 cosine theta. Cancelling 2 cosine theta to get the integral of 8 sine cube theta d theta. Now that we have converted the original functions into the functions in terms of theta and d theta, we evaluate the integral of 8 sine cube theta d theta. We make use of sine square theta equal 1 minus cosine square theta again, so we separate sine cube theta into sine square theta and sine theta. Replacing the sine square theta part with 1 minus cosine square theta and distributing them to get 8 integral of sine theta minus cosine square theta sine theta d theta. For the first integral of sine theta d theta, using the formula to get minus cosine theta. For the second integral, we try to use simple u substitution method, letting cosine theta be u and taking the differential of u to get minus sine theta d theta. Using the power formula to get u cubed over 3 plus c, bringing u back to get cosine cube theta over 3 plus c. We have integrated as 8 times bracket minus cosine theta plus cosine cube theta over 3 plus c for now. We have integrated in terms of theta and d theta. However, the question was expressed in terms of x, so we need to return to the original variable x. Let's go back to the relationship we established at the beginning as x equal to sine theta, dividing both sides to solve for sine theta. Since sine theta equal to x over 2, which means x being opposite and 2 being hypotenuse in a right triangle. Let's draw a right triangle based on this information. For both cosine theta parts, we can express as square root of 4 minus x squared over 2, since cosine theta is the ratio of adjacent over hypotenuse. Replacing both cosine thetas with the square root of 4 minus x squared over 2 and simplifying the expression to get the solution as shown. This method allows us to change algebraic functions into trigonometric functions, integrate them in trigonometric forms, and return to the original algebraic functions as solutions. Thank you for watching and see you next time.